Before we get started, let's make sure that you have your exponent notebook, something to write with, and a piece of scratch paper. Take a moment to find those things if you need to. Then turn in your exponent notebook to the back side of your cover page that has our 5 rules on it. Actually, we only have 4 for simplifying exponential expressions. Let's put the 5th, or add the 5th on there. So number 5. No powers of quotients. No powers of quotients. Okay. Then go to your next blank page, and at the top of that page you would label it Unit 1, Day 3, and then copy down this learning objective. Use the division properties of exponents to simplify exponential expressions. All right, next little vocab. I want to concentrate on the word quotient. If you don't remember that quotient is just the answer to a division problem. So let's just say division answer. Next, let's consider a little example here. I'd like to go ahead and make a line across my page to separate the vocab for this next example. Let's consider this example here. Let's say that I have the power 3 to the 5th over the power of 3 to the 3rd. So here I have a quotient. I have a division problem. Now you'll recall that 3 to the 5th just means that you have 3 times itself 5 times in the numerator. 3 to the 3rd means you have 3 times itself 3 times in the denominator. Now through division we can begin to cancel out some of these 3's. 3 divided by 3 is 1, and so forth and so forth. So here we have on the top just two 3's left over. So we have 1 times 1 times 1 times 3 times 3. That's just 3 squared, or 9. What I want you guys to see here with this rule is that if you take the 5 from the numerator and the 3 from the denominator and just to subtract them, you get the 2 in your final answer. There's the shortcut, and that's what we call the quotient of powers property. Take a moment to copy that down for me. All right, let's do a few examples. I made a little X on my paper here so I can do 4 examples. Here's the first one. Let's say I have 2 to the 7th over 2 squared. Since I have the same base on each one of these powers, in other words, there's a 2 on the bottom, that allows me to subtract their exponents. So 7 minus 2 gives me 2 to the 5th. Okay. There's no 0 or negative exponents. All of the other rules are satisfied for simplifying expressions, so I can leave it just like that. If you also want to write it as a 32, that's fine as well. Second example. 4 squared divided by 4 to the 5th. Okay, same base, so we can subtract their exponents. But here we've got 2 minus 5. Well, 2 minus 5 is